explain most precisely so that I can able to answer your query, sir? And Dr. Shivasakti? Am I audible, Dr. Shivasakti? Yeah, regarding literature information. So what kind of literature you are interested in? PhD literature information means I could not get you. Actually, what basically it represents means, can you elaborate that PhD literature information means? Are you looking into blockchain, or are you looking into blockchain with a deep learning, or you are looking into the deep learning? What kind of literatures? If I will say what I understood from your questions, maybe you are looking into the blockchains, or you are looking into the deep learning. So you can obviously get it from this IEEE transaction papers, or some papers you can get it. So already I have mentioned few of the references in my work. You can have a look into that. You can get more clarity as well as more detailed informations. I hope I have answered your queries. Yeah. Okay.
Good afternoon, sir.
Yes. Yes. Good afternoon. Yes. Am I audible?
Sir, audible, sir.
Yes. Please ask.
Sir, means if we combine blockchain with AI,
yes,
what are the main benefits we are getting from utilizing AI in blockchain?
So already in my slide, I have told you that this blockchain is a decentralized network, and this deep learning is a centralized network. And I have told that when we are using the blockchain in deep learning, basically it can overcome this prone to single point failure. Now, what is this prone to single? If there is a failure at one point, then the total system get collapsed. In case of deep learning application, because we are keeping all our data in a single point, or we are keeping all these data in a single server. So this single point failure can be overcome. So that what exactly we are or getting the benefit of this blockchain for these deep learning applications. There are some other benefits of integration of this blockchain with deep learning, that is automated and trusted decision making, efficient data market management, data security, better model building for prediction purposes, model sharing, enhancement of the robustness of DL-based systems, etc. So already in the morning session, we have discussed all these things. I hope it is clear to you. Am I right, sir?
Yes, sir. Yes, sir. Yes. Fine, sir. Thank you.
Thank you. Yeah. Now we'll come to the discussion of certain questions. I don't think anybody has any questions in the chat box. Let me see. Yeah, no more questions. Already Professor Vidyasagar replied that he will discuss about the literature about the blockchain tomorrow. I hope Dr. Shivasakti has got the answers, and Professor Vidyasagar will discuss these things. Next, already I have shared one Google document in this chat box. Now I will share the questions you please have a look into the questions and take some 30-minute time to answer all these questions. Let me share the document. Yeah. Yeah, I have shared the questions in the WhatsApp group, and I have shared the Google link, uh, Google Doc link in the chat box. So you take 30-minute time to answer all these questions. Then we can have a discussion about the today's morning session as well as the afternoon session, whatever we have learned from this today's Which slide is? Welcome you all. Am I audible? I hope now it's the time for discussing. So I have shared some of the questions that we have discussed in last 4 hours of our lecture classes. So the first question that I have given that give an example of automated decision making ADM using blockchain as well as deep learning. So if you look into the Google Doc, so what the people have written, so business, healthcare, transport. Also, people have written business, healthcare, transport, healthcare. Yes. So yeah, healthcare and transport. Yes, fine. So the automated decision making, that is ADM, is popularly used for many kind of applications. And if we'll mention a few, basically this used in various contexts, including public administration, business, healthcare, education, law, employment, transport, media, entertainment, as well as many more. So I hope everybody has answered these questions very nicely. So next we'll come to the next question. That is question 2. Which of these are the regions for deep learning recently taking off? The bits are given here, has access to a lot more computational power. Neural networks are brand new field, or we have access to a lot more data. Deep learning has resulted in significant improvements in important applications such as online advertising, speech recognition, as well as image recognitions. So what are the regions deep learning are recently taking off? So let me see the answer what people have given. Yes, this option A, C, and D that has access a lot more computational power. We have access to a lot more data, as well as deep learning has resulted in significant improvements in important applications such as online advertising, speech recognition, image recognition, as well as many more applications. So in our morning session, we have discussed what are the applications of deep learning as well as blockchain for many kind of fields. So the correct answer is A, C, D. So let me check what others have written. A, C, D. Yes. A, D. So here C is also the correct answer. So you can see here C is also the correct answer. A, C, D. Yes. This is also the correct answer. Yeah. Answer 2 is false. Why it is false? Which of these across deep learning recently taking off? Okay. Next, we will come to the next question. Which of the following deep learning models uses back propagation? So the third question says, Let me go to the third question. Which of the following deep learning models uses backpropagation? Here we are talking about convolutional neural network, multi-layer perceptron network, recurrent neural networks. So already we have discussed in our morning session that these convolutional neural network, multi-layer perceptron network, recurrent neural network, these are nothing but deep learning networks. And in all the cases, we are basically finding the weights. So the correct answer is all the networks uses backpropagation algorithm. So the correct answer is all the above, that is D. So let me check how many of you have written correctly. So answer D, yeah. Then next question number 3, D. Yes, question number 3, B, C. Yeah, this is wrong. Then question number 3 is D. Yeah. Question number 3 is all the above, that is CNN. Yeah. Multi-layer perceptron network, recurrent neural network. Next, we'll come to the next question. Question number 4. Neural networks can be used in DAS, that is regression problems, classification problems, clustering problems, as well as all the above. Yes, if you look into the neural networks, the neural networks can be used or regression problem. We have discussed one of the example of regression, how this regression problem gives rise to underfitting, overfitting, as well as critical fit. Classification problems, if you look into this classification of the diseases from the symptoms, it can be used for clustering problems also. So the correct answer for this neural network can be used for all the above, that is regression problems, classification problems, as well as clustering problems. We can able to perform all kind of task by the help of this neural network. So the correct answer is D. So now we'll see what the people have answered this question. Question 4D, all the above. Yes. 4, this is D. Then question number 4, this is also D. Yeah. Question number 4, this is also, yes, written D. Yeah, question number 4 is also D. Yeah. All participants have written the correct answer, that is question number 4 is a D. Next, we'll move to the next question. Question number 5. Which of the following is a loss function? Here the options are given, that is sigmoid function, cross entropy, ReLU, all the above. If you look into the sigmoid, that is as well as cross entropy. So already in the morning session we have discussed cross entropy, the loss function, and basically sigmoid function as well as softmax, ReLU, these are activation functions. So the correct answer is for question number 5 is that is called cross entropy. So why these loss functions are used? To these loss functions has to be minimized to improve the performance of deep learning algorithms. Let me check how many of you have written the correct answer for question number 5. Yeah, question number 5, option B, cross entropy. Next, question number 5, yeah, B, cross entropy. Next, question number 5, yeah, C. Okay, this is the wrong. The cross entropy is the cross that is loss functions that we are using. 5B, yes, this is also correct. Then question number 5, C, ReLU is the loss function. No, this yeah, this cross entropy is the loss function. So make it correct. Next, we'll go to the next question. What does a gradient descent algorithm do? So before coming to this answer of this, I just want to tell what is this gradient descent algorithm exactly. So what is our aim in case of regression? In case of our regression problem, we are finding the value of W in such a manner that the error has to be minimum. That means your prediction value will become equal to almost to the original output. So that means y hat will become equal to I. So this y hat, that is the prediction, depends upon the weights. So the weights has to be adjusted in such a manner that the error has to be minimized. So the gradient algorithm or gradient descent algorithm basically finds the gradient and it will optimize the weights in such a manner that the error has to be minimum or the error has to be reduced. So if you look into the options that are given here, tries to find the parameters of a model that minimize the cost function. Yes, it basically tries to find the parameters of the model that minimizes the cost function. So here the parameters are nothing but the weights. Adjust the weights are the input layers. Yes, correct. So we can say that it will adjust the weights at the input layers. So C, both A and B. This is also correct. D, none. So the correct answer for question number 6, both A and B. So that means it tries to find the parameters of a model that minimizes the cost function, as well as it adjusts the weights at the input layers. So that means it will both A and B. So let me check question number 6. That is equal to, here it is B. Question number 6, C. 6 is C. Yeah, this is 6C. 6C, both here. Okay. And next, we'll come to the next question. Which strategy doesn't prevent a model from overfitting to the training data? So, before coming to this answer of this question, so I have missed this question number 7, I hope so. Yeah. Which of the following is the correct order for the convolutional neural network? So, in case of convolutional neural network, the first operation that we are performing is called the convolution. Then we are performing or we are applying ReLU activation function, then max pooling, then flattening, then full connections, etc. So the correct option is convolution. ReLU is missing here, max pooling, then flattening and full connections. Here max pooling is coming first, then convolution. So this D is not the correct option. C, flattening, max pooling, convolution, full connection. This is also not the correct option. So the correct option is convolution, max pooling, flattening and full connections. So let me check how many of you have written it correctly. So the question number 7, convolution, max pooling, flattening as well as full connection. Yes, correct. 7A, 7A, correct. Next 7A, yeah, correct. Then next 7A, yeah, correct. 7C, yeah, this is wrong. This is order is not correct. Okay, so almost all the participants have written this answer correctly. Next, we will come to the next question. Question number 8. Which strategy doesn't prevent a model from overfitting to the training data? So already in the morning half session, we have discussed about there are 3 conditions. One is called underfitting, another is called overfitting, and another is called critical fit. During underfitting conditions, the training error, we try to make the training error to be minimized. During the overfitting conditions, during underfitting condition, the training error is not sufficiently low, and during overfitting condition, the gap between the training error and testing error is too high. So, which strategy we have to follow to prevent the model for overfitting? Whether we will go for dropout. Basically, in dropout, we are dropping some of the neurons. In case of pooling, we are just pull out the data. And the data augmentation, in augmentation, we are basically increasing the size of the data, yearly stopping. So the best option for this is called pooling operation. As already you have discussed in the afternoon session, this pooling, there are 3 types of pooling. One is called max pooling, average pooling, as well as global pooling. And the pooling is the correct answer to overcome the overfitting condition in case of the training data. So let me see the answers. So the correct option is 8 is B. Yeah. So this is A, 8B, correct. So here 8B. Yeah, correct. 8B. Yeah. Most of these participants have written this answer correctly. So next we'll come to question number 9. What is the difference between machine learning as well as deep learning? Already in the morning half session we have discussed the difference between machine learning and deep learning. That in case of machine learning we have a feature extraction block, but in case of deep learning we don't have any feature extraction block. The deep learning can able to extract the feature from these different layers, because we have a large number of layers, and the layers which are very close to the input can able to extract some basic features like edges, and the layers which are very far away from the input, they can able to extract some porous features. So the main difference is that in case of machine learning there is a feature extraction is required, but in case of deep learning the feature extraction is not required. Other difference we can say that deep learning is a subset of a machine learning algorithm. So this is the difference, the basic difference. Let me see what the answers have been given. Question number 9. So machine learning uses algorithms to parse data, learn from the data, and make informed decisions on what has learned. Deep learning structures algorithms layers to create artificial neural network that can learn and make intelligent decisions on its own. Yeah. So question number 9. Machine learning uses algorithm parse data. Okay. Question number 9. DL is a subset of machine learning. Okay. Question of machine learning uses algorithm to parse data or parse data, learn from that data and make the informed decisions based on what it has learned. Deep learning structures algorithms in layers to create an artificial neural network that can learn and make intelligent decisions on its own. Okay. Question number 9. Question number 9, there is no options are there. Okay. Okay. Next. Okay. Mostly you have answered this question correctly. Next, question number 10. What is the role of activation functions in neural network? Already we have seen this. There are many type of activation functions starting from ReLU, tan, hyperbolic X, sigmoid functions, etc. So this role of activation function, that a neuron is activated or not, or in other words, we can say that it can overcome the vanishing gradient problem, because we know that during the process of gradient calculation, we are calculating the weights, and after getting the optimum value of the weight, we can make this MAC to be very, very low, or that is to be minimum. So in other words, we can say that it will make a non-linearly separable class to a linearly separable class. It will increase the dimensions. So these are the few of this role of these activation functions. Let me see what is the answers. So question number 12, hyperparameters are the parameters. Sorry, 12 is not the, sorry, question number 10. Role of activation function in a neural network decides whether the neuron should be activated or not. Okay. Question number 10, role of neuron should be activated or not. Okay, role of activation is a network decide whether neurons should be activated or not. Okay. So yeah, everybody has written this answer correctly. Okay. Pooling, it is a layer CNN. Okay. So next question, we'll look into question number 11. What are the application of recurrent neural network? Already we have discussed in the morning session that recurrent neural network is otherwise known as your long short-term memory network. There is a feedback from the output to any of the hearing layer. There is also a self-feedback. And we have seen that this type of neural network are mainly used for text data, speech data, wherever the data size is very large. And this recurrent neural network also can be used for ECG for arrhythmia detections or kind of some time series data. Basically, people are using this recurrent neural network. So let me see what is the answers. So machine learning, question number 11, that is machine learning forms of a subset of artificial where they use statistics, algorithm, machine learning data. There deep learning and part of this machine learning. No, oh, yeah, okay. Question number 11. What others are? Machine translation, speech recognition, video tagging, language modeling, and generating text. Okay. So question number 11, machine translation, speech recognition, language modeling, generating text, video tagging, generating image descriptions. Question number 11, machine translation, speech recognition, language modeling, generating text, video tagging, and generating image description. Yeah, fine. So this machine translation, language modeling, generating text, video tagging, and generating image descriptions. Yeah, fine. So everybody has written this answer correctly. Next is question number 12. We'll look into the question 12. What are the hyperparameters? Basically, these hyperparameters controls the performance of this deep neural network. So there are many hyperparameters have been used. One is called epoch, learning rate, batch size, etc. So let's see what is the answer is given. Question number 12. Hyperparameters are the parameters that are explicitly defined to control the learning process before applying the, yeah, correct. So 12 hyperparameters are parameters that are explicitly defined the control. Okay, 12 the control the learning process. Yeah. Next 12 hyperparameters are the parameters explicitly defined to control the learning process before applying. So an activation function decides whether the neurons should be activated or not. Maybe okay, activation functions. So maybe, yeah, he has made this numbering different maybe. Okay, so basically the hyperparameters are nothing but which controls the learning process. This is nothing but epoch, learning rate, batch size, etc. Now we'll look into the next question, that is 13. What will happen if the learning rate is set too low or too high? So if the learning rate is too low, what will happen? To get the optimum value of weight, it requires a lot of time. That means it is very, very sluggish. If the learning rate is too high, then the optimum value may not reach, but the learning process becomes faster. So sometimes what will happen if the learning rate is not critically set, or that means some critical value of this learning rate, then what will happen? It will get diverged out. We cannot get to the optimum value. So in case of low learning rate, it is very, very sluggish, and in case of high learning rate, this process will become faster, but may not. It doesn't guarantee that it will reach at the optimum value. So let's see the question number 13. So back propagation. So no, this is not the correct answer. 13. Training will progress very slowly in case of too small learning rate. 13. That training will slow or fast. Correct. 13. Training will progress very slowly. 13. Training will progress very slowly. Yeah. Okay. So now next we'll move to the next question. That is, what is the difference between epoch and batch in deep learning? If you look into the epoch, that is one iteration over the entire data set is known as the epoch. Or that means we can say that more epoch, or that means more number of times the weights are changed, and that means the training process or learning process go from underfitting condition to the overfitting condition. Or in other words, we can define when the entire database is passed forward and backward through a neural network, that is represented as epoch. And if you look into the batch size, data is divided into several batches when all the data cannot be fed to the neural network. So batch size, the number of samples processed before the model is updated. The number of epoch is the number of complete passes through the training data set. Then question number 14, yeah, batch size, number of samples processed before the model is updated, and the number of epoch is the number of complete passes through the training data set. 14, the batch size is the number of samples processed before the model is updated. The number of epoch is the number of complete passes through the training data set. Next, the batch size is the number of samples processed before the model is updated, and the number of echoes is the number of complete passes through the training data set. Okay. So next we'll move to the next question, that is equal to 15. What is a deep neural network better than, why is a deep neural network is better than the shallow neural network? Obviously, in case of shallow neural network, we have less number of layers, and in case of deep neural network, we have more number of layers, so it can extract more features, or that means we can say that it is more efficient in terms of computation and number of parameters. Or so next, look into the answers. Question number 15, more efficient in terms of computation as well as number of parameters. 15 not there. Okay. 15 more efficient in number of computations and parameters. More efficient. Okay. 15 more efficient in number of parameters. Fine. What is GIAN? GIAN basically stands for Generative Adversarial Network, which consists of a generator and a discriminator. This generator is basically used for generating the fake data, and discriminator try to decide that which one is fake and which one is real. So let me check the answers. That is 15, generative adversarial network. 16, yeah, generative adversarial network. 16, generative adversarial network. Yeah, 16, generative adversarial network. Yeah, fine. Everybody has written it correctly. So next question is 17. What is the reinforcement learning? Already we have discussed multiple number of times. So what is the reinforcement learning? Basically, it is maximizing the reward, which is based on the principle of feedback. So let's see what the answers have given. Reinforcement, reward, penalty. Okay. Maximizing reward. Okay, more efficient. I know. Is a science of decision making. Learning is the science of decision making. Okay. Yeah, it is a kind of science of decision making. We can say in other way. Next questions. Yeah. How to calculate the deep nodal performance? Already have discussed that is top 5 error rate. Accuracy, etc. also can be used for calculating these performances. Let me check what is the answers given for question number 18. So automatic verification, manual verification, manual people cross validations. Okay. Question 18, verification, manual k-fold cross validations. 18. What is top 5 error accuracy? Okay, 18 automatic verification, manual verification because manual cross 18. Yeah, everybody has answered the questions correctly. What is a deep learning framework? That next question. What are the deep learning frameworks? The deep learning frameworks are TensorFlow, Keras, PyTorch, Cafe, Piano, etc. So let me check the answers directly. This is question number 19. Designing, training, validating deep neural networks to a high-level programming interface. 19. PyTorch. 19. Designing, validating deep neural networks to a high-level programming interface. Okay. 19. Validating deep neural to a high level. Okay. Next is question number 20. What are the benefits of combining AI and blockchain? Already we have answered these questions multiple number of times. What is the benefit of this blockchain as well as AI when it is combined? So this is basically a few of these answers are elevated data security, automation, cumulative judgments, enhanced robustness, etc. So let me check what are the answers you have given. That is greater transparency, enhanced data quality, improved scalability, greater flexibility. Okay. 20, greater transparency, enhanced data quality, improved scalability, greater flexibility. Yes. Greater transparency, enhanced data quality, improved scalability, and greater flexibility. Okay. Yeah. Everybody has answered the questions correctly. Next, we'll move to the next question. Question number 21. What are the application of blockchain in AI? It has numerous applications from transport, healthcare, industry, etc. So let's go to the answers directly. Question number 21. Money transfer, smart contract, personal identity, security, healthcare, logistics. Yes. 21, traffic management. Okay. 21, money transfer, smart contracts, personal identity, security, healthcare, logistics. Yeah. So everybody has written these questions correctly. Next is, what are the sectors using blockchain and AI? If we look into the sectors, there are many sectors are using blockchain and AI: healthcare, real estate, financial industry, etc. So let's say this is the now we'll go to the question number 22 answers: real estate, media, healthcare, financial industries. Yeah, 22 is not there. Yeah, okay. Real estate, media, healthcare, financial industry, etc. Yes. All of you have answered these questions very nicely. You have responded correctly to these questions that I have asked, and we have discussed in the morning session as well as in the afternoon session. So now it's the time for stop it here. Anyone want to discuss anything? Okay, so we'll stop it here. Tomorrow we'll meet and we'll inform you what time we are going to start the program. If anyone has any questions, please type in the chat box. Maybe tomorrow we can have a discussion about this. Thank you all. So we'll stop here.